So we moved on to part B of our torque problem, and part B says that our friend decides to help us screw the bolt in. And what he actually does is he changes the torque from 7 Newton meters to negative 10 Newton meters. And we want to know what is the force he's applying if his force is perpendicular to the wrench. So if we look at our little wrench diagram here, we have the length of our wrench in red, and we have our force that we've been applying since part A in purple. And what we're going to do first is we're going to draw a vector that represents our friend's force, because the net torque of this wrench being moved is changed from a positive torque to a negative torque. So if our torque used to be a positive 7 Newton meters, then our friend has to be applying some amount of negative torque in order to change the net torque to negative 10. And, well, that's just really simple to calculate. Our net torque is equal to our torque plus our friend's torque, and negative 10 will just equal our torque plus his torque. And so his torque has to equal negative 17 Newton meters. So our friend is applying this huge amount of negative torque compared to our measly little 7 Newton meters. And we just want to represent his force on our wrench. And we can use the right hand rule to help us out with that, because we know that our friend's force has to be perpendicular to the length of the wrench. So it's either going to be pointing this way or it's going to be pointing this way, up this way or down this way. And we can use the right hand rule, because if our torque was positive and we point our hand along our vector and curl our fingers in this direction toward the length of our wrench, then we have our thumb pointing out toward us so that we know that we have a positive torque. But now we have to make sure that our friend's vector is in such a direction that it will give us a negative torque, where when we curl our fingers in, our thumb will be pointing away from us, and that will actually be his vector pointing downward, because we want our fingers to curl this way so that we get a negative torque, and we do that by curling our fingers this way toward the length of our wrench. So now we actually want to know what force he's applying so that the net torque was changed to negative 10 Newton meters. And we already solved for what our friend's torque was, negative 17 Newton meters, and we had to do that by adding our torque to his torque to equal the net torque. So we're just going to take our friend's torque, and we can just do the same thing that we did last time in part A to find his force, the force of our friend, because we know that torque is equal to the force applied times the length of our wrench times the sine of theta. And actually sine of theta is just going to equal 1 here, because the sine of 90 degrees is just equal to 1. So we can ignore that, and so we can say that it's just going to be equal to the force of our friend times the length of our wrench. So we can solve for the force of our friend because we know that our torque of our friend is equal to negative 17, which is then equal to our force times 0.1. And all we have to do is divide by 0.1 on both sides, and we get that the force our friend applied is equal to negative 170 newtons. And with that, we can move on to part C.